Absolute value means how far away from 0 something is on the number line. So how far away is 2 from 0? That's 2 units away. How far away is -1? 1 unit away. You can't have a negative distance, so absolute value just means how far is it from 0, so long story short, it makes it positive. When evaluating expressions, absolute value bars act as a grouping symbol, which means perform any operations inside those bars first. First, let's practice just how they work. Let's plug in the -7 that they gave us. So we have 10 minus absolute value of -7 plus 5. Grouping symbol, so do the absolute value stuff first. Also make really nice, long, skinny absolute value bars because we don't want to confuse them for ones. -7 plus 5 is -2. Almost finished. Now we have 10 minus. The absolute value is always positive, so +2. And the answer is 8. Let's try one more. We're plugging in -2 for x. Absolute value of 4 times -2 plus 3 minus 1. That's going to be -8 plus 3 minus 1. -8 plus 3 is -5. And the absolute value of a -5 is +5. So 5 minus 1 is 4. Final answer. It might be a good idea to pause while you do problem C on your own, just to make sure it's making sense. Let's plug in -2 for y. 3 minus absolute value of 2 times -2. 3 minus 2 times -2 is -4. Bring down the 3. -4 plus 1 is -3. And the absolute value of a negative is a positive. So we have 3 minus 3 is 0. Now that we've just practiced working with absolute values, let's try solving some equations. There are 3 steps to solve absolute value equations. Step 1, make sure the absolute value is by itself. So please write in the box, get absolute value alone. Now for A and B right here, you can see they're already alone. It's not as if we had extra stuff with them, like maybe a +3 at the end. We don't have anything like that. So we can skip straight to step 2, which is to solve the cases. Solve each case. And I'm putting case in quotes because I'm about to tell you what that means. Example 2 part A, I'll set up my cases. You just write the same thing again, but without absolute value. Case 1. Case 2 is almost the same, write the same equation without absolute value, but this time you have to make the thing that's not in the absolute value opposite. So opposite of 9 is -9. Those are your cases. They're almost identical. So solve these by subtracting 12. You should have -3 equals x. Subtract 12. You should have -21 equals x. And now I'm finished solving my cases. Very last step. I'm not a stickler about requiring that you always check your work, but on step 3, it's actually mandatory that you check your solutions in the original problem. So there's something unusual with these ones where you have to check it every time. So let's check the -3. I plug it back into the original problem. 9 equals absolute value of negative 3 plus 12. I simplify. Negative 3 plus 12 is 9. And you better believe that the absolute value of 9 is 9. So check mark, it works. Put a box around your answer. That one's all done. Let's check the negative 21. We will have 9 equals absolute value negative 21 plus 12. We simplify. Negative 21 plus 12 is negative 9. And yes, absolute value of a negative is a positive, so this checks out also. Check mark, put a box around it. We are done. The next one should be pretty much the same. I would recommend pausing the video to try that on your own. So we will have 8 equals y plus 5, and 8 equals y plus 5, but we make the 8 opposite. We subtract 5 on both sides to solve. So we have 3 equals y, and negative 13 equals y. We finished solving the cases, so now we check. We have 8 equals absolute value 3 plus 5, and 8 equals absolute value negative 13 plus 5. Three plus 5 is 8, so that works out. And negative 13 plus 5 is negative 8, so that one also works. Let's try a few more. Because an absolute value, it has to be positive. If you get a negative answer, that can't be true. So you'll say it's no solution. So let's get started on example 3. Basically, you're looking out for something to end up like this. If this is saying an absolute value is a negative, you know that's impossible. So watch out for that, because that's a loophole where you don't have to do any work on the problem. Example 3, do we have that? No, it's equal to a positive 1. So here goes. We solve so the absolute value is by itself. Subtract 8 on both sides. Absolute value of 3x minus 2 equals negative 7. And hey, now it's an impossible equation. Absolute value can't be any negative number. So we're done, but you can't leave your answer like this. To get credit, you have to show that you concluded there is no solution. So draw a circle with a slash. Let's try problem B the same way. Step 1, is it a no solution? Nope, because it's just equal to a plain old positive 6, which is fine. Step 1, get the absolute value alone. Divide that negative 2 out of there. So we have absolute value of 3a equals negative 3. And hey, this is a no solution. You can't have an absolute value equal a negative number. So write no solution and you're done. Now let's try one that only has one solution. Sometimes you get a solution that even though you did all the steps right, it doesn't work. That's called an extraneous solution. So example 4, here goes. The absolute value is by itself. That was step 1. Ready for step 2. Split into your cases. So you'll have x plus 10 equals 4x minus 8. Your other case, pay attention to this one, will be x plus 10 equals the opposite of this whole chunk. So it'll be negative 4x plus 8. Everything goes opposite. Now solve. Subtract 10 on both sides. Negative 3x equals negative 18. Divide by negative 3 on both sides. X equals 6. I'm using up a lot of my space, and I have to remember to check, so I'll remember to do that later. Other side, do the opposite to get the x's in one place. So I get plus 10 equals 8. Okay, have you noticed the mistake I just made? The 4x is wrong because it was 4x plus a 1x because of the invisible 1. That should be 5x. Now it's a two-step equation, so get rid of the 10. 5x equals negative 2. Now divide to get the 5 out of there. So we have x equals negative 2/5, also negative 0.4. Okay, we've got our two solutions. Now we have to check. The fraction isn't pretty, but we're almost done with the problem. So here's my first check. I have x plus 10. Oops, what am I doing? I didn't plug in the number. Absolute value of 6 plus 10 equals 4 times 6 again. Don't forget to plug in for all the x's, minus 8. Now we simplify. This becomes absolute value of 6 plus 10 is 16. 4 times 6 is 24. Absolute value of 16 is 16. 24 minus 8 is 16. Check. So that means 6 is a good solution, and you should put a box around it. Now we'll check the other solution, negative 2/5. Check. So you write absolute value of negative 2/5 plus 10 equals 4 times negative 2/5 minus 8. Trust me, I tried to find a problem that wasn't so nasty with all the fractions, but this is the best one I could find. Now we simplify. What's negative 2/5 plus 10? You're welcome to plug that into Desmos or any calculator. It'll be 9 3/5. I'll show you typing that in. You just go to Desmos, negative 2/5 plus 10. So you have negative 2/5. Click out of there, plus 10 equals 9.6. It's fine with me if you write the decimal or the fraction. So I wrote the fraction. Equals 4 times negative 2/5 is negative 8/5. Again, you can do that in your calculator. 4 times negative 2/5. Negative 1.6. Also known as negative 8/5. Almost finished. Absolute value of 9 3/5 is 9 3/5. Negative 8/5 minus 8 is negative 9 3/5. So that's false. Positive equals negative. So please do several steps now. Slash that equal sign because that's false. And then cross out where we wrote x equals negative 2/5 earlier. That one is an extraneous solution. I'm going to give it a little label. That was an extraneous solution. We didn't make any mistakes, but we still got an answer that's no good. Last thing, let's throw in some inequalities. Example 5 part A. First thing is get the absolute value by itself. It is that way, so we're ready to split into cases. You have x plus 7 is greater than or equal to 2, and x plus 7 is, remember to make everything opposite, including the inequality, less than or equal to 2. Now we solve each of these cases by subtracting 7. X is greater than or equal to -5. Other side, subtract away the 7. X is less than or equal to -5. Whoops, I just realized I forgot to make the 2 opposite. That because you do the inequality opposite and the number opposite. So I will fix that really quickly. I'm going to write in a different color pen, so if you're looking back you can see how I fixed it. That should be a -2, so then we get a -9. All right, we got both of these. Now here's the last thing you need to do. Good news, you don't have to check for the inequalities, but you do have to say, is it this and this, or is it this or this? So here's how you know. The trick that I use to remember is you have greater and less than. Greater and less than. Do you see what I did there? Greater and less than. We started with a greater than symbol, greater than. So I will write or in between my 2 answers. Done. Next one, very similar. We get our cases. X minus 3 is less than 8. X minus 3 is greater than -8. I'm going to rewrite my inequality because it looks like a 7 almost. Now we solve these. All right, last step. We don't have to check, but we do have to say or and. So look at the original inequality. This is a less than, less than, less than. So write the word and you are finished.